Hello, my fellow color nerds. After the winter break, we continue with our Baselight learning program. Today, I cover a fundamental topic, which is required in the full understanding of the Baselight software. I talk about the temporal component of Baselight. That means frames per second. Okay, let's begin. Let's talk about the temporal component of Baselight, and with temporal, I mean frame rates. Baselight works in a fixed frame rate raster, so every scene has one working frame rate. So this is basically the frame rate of each timeline, and this frame rate is locked and fixed per scene. So once you created the scene with a fixed frame rate, you cannot change it afterwards. If you need to change the frame rate of a scene, you need to create a new scene with the new desired frame rate and then copy the strips over. When we examine the underlying mechanism, we see a principle that we find at many points in the Baselight software, which is input, intermediate, output as three stages, and basically two mappings, one from input to intermediate, and then another transform or mapping from intermediate to output. Intermediate for the frame rate means working stage, or basically the working frame rate of a scene. And in today's session, we want to focus only on the input mapping side. So only on that mapping from input into the working stage. In the next session, we will then focus on the second mapping here from working to output. For example, how to deliver to multiple frame rates from one scene. But today we will focus on the input mapping. So we will examine how do we create and adjust speed effects on shots, what different resampling methods do we have available, and how can we manage different source frame rates in one scene. Let's jump into the timeline. Okay, here we have our first footage clip. And let's examine the temporal parameters here inside layer 0. So here we have the sequence parameters, and in this section here, in the frame section, here we deal with the temporal component of each clip. We have an input frame rate, we have an offset, frame increment, etc. The first parameter I want to take a closer look at is the offset. Offset defines the mark-in point in the footage. So here we're dealing with an .mov, a QuickTime clip, and offset 20 means that we are not seeing the first 19 frames of that source clip in the timeline, but the first frame that we have here available is the 20th. So the offset is the mark in the source, basically. I'm adding counters to the cursor so that you can follow easier what I'm actually doing. S is the source timecode, R is the record timecode of the scene. And now I'm clicking into the offset field. When I'm pressing up arrow or down arrow on the keyboard, you can see that I can now slip the clip by single frames. If I hold down Shift, you can see now I can slip it by 10 frames with each press. And if I'm holding down Shift Command, I can slip it 100 frames. This specific clip does not have enough footage in the handles, so we see the gray media offline image. But this is a very easy way to slip a clip by a fixed amount of frames, for example. So I'm putting this back to 20. Moving to the frame increment. Frame increment is the playback speed of each clip. Basically, it defines how many frames do we move in the source for moving one frame forward in the timeline. So if frame increment is set to 1.0, it means for one frame forward in the timeline, we move one frame forward in the source. So this is the most common frame increment. In other software, this is often referenced as playback speed of 100%. So if you have a percentage number, just divide it by 100 and you will end up with the frame increment in Baselight. This means if I set this to 0.5, now we have a 50% slow motion. So only every other frame now in the timeline we see the source clip moving. So now if I hit play, we see maybe it's not visible via zoom, but we now have a little bit stuttering playback here. Another thing we can do is, let's set this back to 1. We can hit reverse, and so we can do also reverse frame increments. Now I have it set to -1. That means now we're playing back the clip in reverse. And obviously we can also use different numbers for negative frame increment. I'm going back to my 50% slow motion effect here on the clip. What we already noticed is that every frame is now doubled in playback. So we see double frames, which will cause some stuttering. And the reason for that is the resampling method. So per default, each clip is resampled with the default resampling method, which you can define in the scene settings. And the default for Baselight is snap to frame. This means use the nearest source frame that you have available for the resampling, but never interpolate any new frames during the resampling. So this means the algorithm can only skip frames or double frames. But the huge advantage is we will never see any kind of bad image artifacts that might happen due to bad temporal interpolation. So the still images should always be clean. The only thing that we might notice is stuttering playback. The other resampling methods that we have available are mix nearest frames. Now I will move to a frame that is basically a mix, or let me find another one where the boy moves the arm a little bit faster. So here we can see that. So now the software interpolates new frames based on the neighboring source frames, and it just mixes them together. So we can see these, for example, here like ghost-like images in fast motion. And in some cases, that might be a good method, but in other cases, it might look a little bit weird. And a third alternative is optical flow. So this is an advanced algorithm which tries to interpolate new frames based on motion vectors that it analyzes from the source clip. So if it works, optical flow usually gives the best and smoothest results, but there's always a risk of artifacts in the image. Here, for example, we can see also some kind of ghost-like effect on the hand. Then we could try to use different options here for the optical flow algorithm. You have different quality presets and different smoothing presets. But in the end, you should always carefully examine optical flow results for artifacts and if they are acceptable. With handles, we can tell the resampling algorithm if it's allowed to use handles of the clips beyond the cuts in the timeline. So if you're dealing with a chopped up sequence where basically cuts are really baked into the file and you just added cuts in the timeline, then you would not want to use handles for temporal interpolation. Or when you're having slate frames in VFX shots and you don't have any additional handles between the used frames in the timeline and the slate frame. Okay, let's move on to the next clip. So what we have here is a retime operator inside layer 0. So this is typically applied when you conform from an AAF or an XML, and the AAF or XML contains dynamic retime effects. If you want to apply these dynamic retime effects automatically to the clips, ensure that during conform you have variable timing set to yes before you start the conform. This option is only visible if the source AAF or XML really contains variable timing. If there are no variable timing effects inside the XML or AAF, that option will not appear in the conform window. So let's have a look at that clip. We can see here that it starts very fast and then we move to normal playback speed. This is also what we see here in the retime graph. So the first keyframe is at frame number 0 and it shows a velocity of 500%. This means we play back the original clip 5 times faster And then while we move forward through the clip, we are slowly moving back to a velocity of 100%. So on frame 28 of the clip, or let's say on frame 28 in the timeline, we are back on a normal playback speed of a frame increment of 1.0. Inside the retime operator, we also have the option to select the resampling method, mix nearest frames, or optical flow with the respective options. And we can also influence the interpolation of the keyframes. So we can switch to a linear interpolation between the keyframes or back to an S-curve, which is the default. Or we could use a manual interpolation, and then we could go in and adjust the Bezier handles of the interpolation. So that can be handy if you're having an offline reference that you need to match with that retime effect here in Baselight. So I'm switching this back to S-curve. I need to show you one important point regarding resampling methods. Here I have an 8K R3D clip in my HD 1920-1080 scene. Also my viewing format is currently 1920-1080. So we're not doing anything special. We're scaling down the 8K to HD and viewing it in the cursor. But what if I want to output a higher resolution in my cursor? If you watched other tutorials, you should know that this basically works in Baselight. If I zoom into the shot, we basically can see the full Ultra HD resolution, although our timeline is only 1920-1080 because the transforms are concatenated. But when I choose another resampling method, which is not snap to frame, we will break the concatenation. We will then force one scale to the working format. So if I switch to optical flow here, what you should see is that we lose a little bit of the resolution, because now what happens is the 8K is scaled into the working format 1920-1080 in order to be resampled on a temporal scale. So temporal resampling happens in the working format. The same with mixed nearest frames. And this is also one of the reasons why I would highly recommend not setting the default method for resampling in the scene settings to anything else than snap to frame. Because if we set this to, for example, optical flow, then basically we're scaling every clip in the timeline to the working format. So this is then a force of process in working format, basically. In many cases, this is not a problem, but you should be aware of that if you want to render to a higher resolution than your working format, you should have the resampling always on snap to frame. Let's move on to another topic, which is mixing different frame rates in the timeline. I'm opening Flux Manage, and what I have here is a set of footage, and this is now shot with a speed of 25 frames per second. And remember, my scene has a working frame rate of 24 frames per second. Here I have that clip selected. If I go to the whole folder, we can see all the clips, but I'm using the one that is the longest. It has a duration of 603 frames. This frame rate here at the bottom is always based on the metadata of the source footage. So in this case, it switches to 25p. Now, if I try to insert that clip into the timeline, we are presented with a pop-up window. What does it say? Mismatched rates. The selected frame rate is different from the scene's frame rate. Using the selected frame rate will cause resampling to occur in the sequence operator. So basically, we are presented with three options. The first one is just cancel. That's not really an option for us. We really need to get that clip into the timeline. So we are left with the other two options. The first one is use the scene rate, 24 FPS. So I start with this one. So now we can see frame increment is 1.0, source frame rate is 24. So now what is happening is we're now playing back the 25 FPS clip at 24 FPS. So every frame in the timeline corresponds to 1 frame of the source. So basically, we're changing the playback speed of the clip. We're now playing it back a little bit slower. So if this would have audio, the audio might go out of sync. But the good thing is we are sure we don't have any kind of motion artifacts, no skipped frames, no double frames, etc. Okay, so what is the other option? I'm zooming out here a little bit, opening Flux Manage again, and now I'm just trying the same thing one more time, choosing the other option. It says use selected rate. What does it mean with selected rate? Selected rate is the frame rate selected here at the bottom of the Flux Manage window. Basically, in most cases, it's the native frame rate of the footage. So in this case now I go with the selected rate, 25 FPS. And we can see now the clip is a little bit shorter because now the input frame rate is set to 25. Frame increment is still 1.0. But now what we should see is that at one point each second we are skipping 1 frame in the source. Now I'm stepping forward, trying to find that frame. Here it is. Here you can see it jumps in the timeline from 15 to 16, but in the source it jumps from 18 to 20. So basically now in every second we will drop one of the source frames, which will give us stuttering playback. And so we could now use one of the frame interpolation methods. Let's zoom in here with these snowflakes. We should see some differences here. So here we can see some ghost images appear, and also optical flow looks a little bit better, but also has a little bit harder time with these snowflakes. So now we are keeping the duration and the audio sync of the original clip, but we need to deal with motion interpolation. So that's the other side of the coin. So that is when the source frame rate does not match the working frame rate. The next thing I want to show you is modifying the source frame rate. So I chop off a little bit from the start of this clip so that we have some kind of offset here. So let's use a fixed offset here of 96. That means we're now discarding the first 4 seconds of that source clip, and I'm changing the source frame rate now to 25. Baselight presents me with another pop-up, and here I don't have the cancel escape route. Frame rate change. Do you want to keep the same offset value in seconds or in frames? So it asks us about that offset here, basically the mark-in point of the footage. Choosing seconds will mean the image shown at the start of the sequence will change. This means if we click seconds, Baselight will calculate the amount of offset from frame number into seconds in the original rate and then apply the same offset in seconds in the new frame rate. But this will mean the in point here will shift. Choosing frames will maintain the same first frame image. That means choosing frames will just keep the offset amount in frames and then use the same offset with the new frame rate. So that means the mark in frame will be the same. So I'm going with frames first. We can see, yeah, first frame stays the same. If you don't know what to do, I would typically go with the frames option. So at least if you know that the mark in point of your clip is already okay, then go with frames. If the mark in is not matching and you're trying different options, then I would probably go with seconds. So I'm redoing it one more time, showing you the other option. If I choose 25 and seconds, we can see now that first frame here shifted because it recalculated the offset from 96 to 100. And obviously, let's reset that. If we have no offset, then we will not see that pop-up window because now it is very clear we want to use the clip from the first frame in the source. There's one last thing I want to show you, and that is how to calculate between frame increment and source frame rate. Because you can use a frame increment instead of changing the source frame rate. You just divide the source frame rate of the clip by the working frame rate of the timeline, and then you end up with a frame increment that you can use in conjunction with the working frame rate. Here's an example. Source frame rate is 60 FPS, frame increment 1.0. If we divide 60 by 24, we end up with 2.5. That means we can use a frame increment of 2.5 with a source frame rate of 24 FPS instead. I will just show this quickly to you as an example. So I go back to Flux Manage and I insert the same clip out of convenience. Here I now select 60p as my selected frame rate. I go with the selected rate, 60p. So here now I have the clip with the source frame rate of 60, and we should see that the source timecode jumps by 2 or 3 frames for each frame that I step forward. Yes, that's happening. Now I duplicate the clip, Command C, Command F, and in this clip here, I go back to 24, use a frame increment of 2.5, and we can see both clips are identical. The question is now, why would you want to convert that? The answer is often you don't have to, but there are some rare cases where having a frame increment is more convenient than having mixed source frame rates. This is, for example, during timeline sort if you want to normalize different speed changes. Okay, that wraps up the first session about input frame rates. One common question regarding input frame rates is there an easy way to quickly identify all shots in a timeline that have not the working frame rate assigned? And there is a method in Baselight, and I can quickly show that to you. And you would do that in Shots View. And there we would create from our All Shots tab as a base a new tab. Typically, I label it Retime. And then here on the bottom for the filtering, I just choose the option Has Speed Change. This is currently set to no. I set this to yes. And now we have a filter here of our timeline of the clips with speed changes. And so you can navigate to these clips here via Shots View, or what you might already know is in the playback filtering, we can now also use that retime filter. And here you can see that now our timeline is basically filtered down to only the clips that have retime effects, also dynamic ones applied to them. Okay, so thanks for watching today. And if you have more questions, please comment below the videos, and see you next week for the second part of the temporal foundation. Bye bye.